So guys, today we are going to learn how to design a reinforced concrete water tank in Revit Structures and do the structural analysis in Autodesk Robot. It's a very simple method if you have the knowledge of structural engineering. So let's get into it. The first step you take is you come to New, then Structural Analysis, then you now click OK. Then you now come to this environment. So the next thing you're going to do is you're going to set levels. You come to North, then you click on this one. Let's say the height of our water tank is 4,000. So this is level 1 and level 2. These levels are changeable. You can write any name you want. You can come to your ground level, then you come to structure, then you come to grid, pick the first grid and you draw. Then you can pick offset. Let's say the width of our structural water tank might be, let's say, what is the width? Let's say 8 meters, so 8,000. Then write 0 there again, and then pick another grid in the X direction. This is grid A. Then you create similar, then pick here, maybe it's a square, 8,000 by 8,000. Good. So we have these now. So the next thing we're going to do is we'll draw our structural walls. So how do we do that? We'll come to structure, then down here, wall, then we'll click there, and we'll pick rectangle. But before we continue, see here is writing depth. We'll change it to height, then we'll connect it to level 2. Then before we proceed, see this wall is 200, right? Yeah, the wall is basic wall here is 200, and we can, let's say we can duplicate it, generic wall 200. We can escape, then edit. Maybe we want to go with 250. Maybe after the structural analysis we'll check for our crack width. If it's enough, we'll leave it at that 250. If it fails in crack, we're going to increase the width, so we'll go with 250 for now. So now pick a rectangle, then we'll now draw here. Escape. Let's see it in 3D. Good, this is it. Let's activate shaded. Alright, this is what we have. So now we're going to draw the floor. We're going to draw the slab, the floor slab. So we'll come to slab here, structural foundation slab. We'll click on that. Then we're going to change the properties, duplicate. Okay, we can just duplicate it, come to here, we can change it. We can also change this one to 250. If it fails in crack width, you can be able to increase the depth. So we have that. So we'll finish. Yeah, okay, so this is it. So the next thing we're going to do is we'll export this to Autodesk Robot. It's a very simple process. If you don't have Autodesk Robot, below the description to this video there's a link to download it. There's a link to download Autodesk Robot, and there are steps on my website, and there are steps on how you are going to install it and crack for free. So now after you've done this, the next thing you are going to do is you come to analyze. Under analyze, you have this robot structural analysis. But before you can see this, you must install this plugin. It's a very simple way to install. It's free, it's totally free. So let me show you on how to download this and install for free. So let's go into it. Good. So to download the plugin for structural analysis, to download the plugin that you will export your drawings from Revit to Autodesk Robot, you come to your web browser and you search apps.autodesk.com. Okay, so this is it, but I have to create an account first. So you click here, you click on sign in there. So when you now come here, it's saying, okay, if you already have an account with Autodesk, you are going to log in. But if you don't have, we'll create account. So let's create account. So let's say HD structures. Email, put your email there, and the password you want to use. Put your password, then you agree, and then you create an account. It's very, very simple. Account has been created. You agree. Good. Now you can be able to download the software. So now that we have logged in, you can see HD structures. I've created an account and I've logged in. So now I can be able to type structural analysis toolkit. I'm using Revit 2020, so I've downloaded this one. Is free. It's free of charge. You can see download here. I'll read. Take your time to read all this. It's important. You now accept. Then you start downloading. It might ask you to confirm your account. You're going to confirm through email. So when it's done downloading now, I just click on open folder. I'll just open to where I downloaded it. See it here. Yes. So if you like, you can turn off your data now, and then you just right click on it. I have already installed it. So you can see if you didn't install it already, you should have seen install. Then I'll just click on install. Good. So now I can be able to come and start my Revit. Good. So now I can be able to now open my drawing and export. So let's do that. So after your installation now, and you come back here. After your installation, you come back here. You come back to analyze. You should be able to see this robot structural analysis. If you can't, comment and tell me why, and I can be able to help you out. So, but before we click here, I always like starting my Autodesk Robot first before as you can see, I'm using Autodesk Robot 2021 and my Revit is 2020, but it's going to export. They mustn't be the same year, yeah, but it always works. But if you have the same year, of Autodesk Robot is still fine. So when I come here, since my walls are going to be shelves, I'm going to click on shelf design. Good. So now I open my Autodesk Robot. I'm not going to do so. Since I open my Autodesk Robot, I'm not going to do anything yet. I'll come back and import my structure first, and I'll come to structural analysis here. I'll click on it. Then I'll click on it. Then robot link. Give it time to load. Okay. So there are options here. Send model. This is direct. You're sending it directly. Then update. Maybe as you are working, you have something you came and add. Maybe you came back and reduce the height or increase the width or depth and stuff like that. You can be able to directly update your model. No stress. Maybe result and stuff like that. So now you are there. So now I can just click on OK. Give it time to go to robot. Okay. Do you want to see report? You can see report. You can see. Okay, you can just close. So now, immediately you close. Now you can come to your Autodesk Robot, and you have this here. So for those that this is their first time of coming to Autodesk Robot, if you want to rotate this, you right click on your screen, you see rotate 3D, you click on it, and then you hold your left mouse button. If you hold your left mouse button, you can be able to rotate this. You can see that this is it in Autodesk Robot. So before and then you can see that here is 3D. If you want this in X and Y, now is you can see that we're in X and Y axis. So we right click 3D, we'll move back to 3D. It's very easy to navigate. So before we progress, before we progress, we'll do some settings. We'll come to tools. Let's start with preferences. Under preferences here, I don't think there's nothing much you can set here. Language, so already United States, English. I don't think it's already the way I want it to be, at least, but you can take your time and try to change what you feel you should change. Then after that, if you feel you can change anything there, and now come to job preferences. This is where I do most of the settings. So I'll just left click on these units. I'll choose metric system. Since I'm using metric system, if you're using empirical system, depends on the method, depends on what you're trying to achieve. Then now they're asking me, do you want to change all the units? Do you want to change all units for metric? Yes, all the units change to metric. Then dimensions, you can see that everything now, my structure meter, rebars, crack width in just as I did that, all this changed. Yeah, all this changed. As if you don't do that now, you'll be changing this one single. You may end up forgetting one thing. Then we're done with that. Under materials, maybe you can choose British. Yes, you can see under materials, I've choose British. Concrete grade 30 for 7, then under database, I'm not going to do much here yet. I'll leave this one for now. I'll come to design code. I'll click on design code. So when I click on design code now, steel, aluminum, you can see I want to, under steel, I want to use, even though this thing doesn't have steel, but for in the future, maybe this is how you get it. You under steel now, you left click, it opens, you click on more, Then I'll BS 5950 UK, I'll move it this side. Then I'll click OK. Do you really want to save these default preferences? I'll say yes. So still connection, I'll leave it on EN9. Timber structure, we won't be doing that. RC structures, ACI, I'm not using ACI. I'll click on more. I'll come to BS. Good, BS 8110. I'll move it this side. Okay. Geotechnical, that's a foundation. So what do I have here? BS 8004, that is for geotechnical. I'll click on OK. Do I really? Yes, I'll accept that. Structural analysis, I don't have much to do there. You can take your time to take a look at all this. Then I can now click OK. Remember, you say member parameters has been defined for code. Convert members to yes. I want to convert it to this. If not, yes, I want to convert it to this. Good. So I have done this. So the next thing, the first thing, you can see how I'm rotating. Left click this, hold this, drag like this. Okay. So the next thing I'm going to do is I'm going to define my thickness, check whether my properties have changed and stuff like that. So if you want to select something, it's simple. As I left click here, after I escape, I'm not in any command. I left click here, I have this, then thickness. I've left click on thickness. So I left click on thickness. I'm having this generic 250, that's panel 5, and I'll be using this generic 250. Let me see. I'm not using this one, so I can't delete it. Layout, no. I'm making use of this generic 250 as my base. No, not that one. I'm making use of this foundation slab. This is what was defined in Revit. Yeah, this foundation slab. So I've clicked it. The properties have come here. So it's not actually 150, it's the name that is showing 150. So I can actually change this to 250. There's the name. Yeah, it doesn't matter. So now the next thing I'm going to do is material. See under material here, I'm choosing concrete grade of 30. I want to work with the concrete grade of 30. Label thickness, you can see TH, the thickness 225 cm, which is 250 mm. Then under this place, you say it's not activated yet. These parameters of foundation elasticity, I've ticked this. Then I'll open this place. Then we're going to find our KZ. We'll find our KZ. So how are we going to do that? So this KZ now is the modulus of the subgrade. So how do you get a modulus of the subgrade? If you can still remember, your structural design, your foundation design is KZ. KZ is given as 40, which is a constant, multiplied by 40, multiplied by SF, multiplied by QA. So what is SF? SF, I would say, is my factor of safety. SF is my factor of safety. QA is my allowable bearing capacity. where is my allowable bearing capacity? What do I say is KZ? I said KZ is modulus of the subgrade. Modulus of the subgrade. KZ is the modulus of the subgrade. Okay. So how do you do this? So let's say our factor of safety is 3. Our allowable bearing capacity is 150. Then our KZ now will be 40 times 3 times 150. If you multiply by this, you should have 18,000. So kilonewton per meter square. So we are now going to insert 18,000 there. We'll add. Okay, we add. You want to already exist, you want to modify it? Yes, we want. So we'll close. We have done that. So the next thing we are going to do is we'll select this thickness of this wall thickness. We'll right click, then we can check the properties. Say select similar by thickness. No, it's very easy. Just say by thickness and everything has been selected. Then we'll now come to our, you can see here the structure is wall. Okay, under structure here, because the calculation will be done by shear. Yeah, that's what we want for that. Yes, reinforcement should be done with shear. Alright, cool, should be reinforced as a shear. So the next thing we can now come to here, to this panel. Click on the thickness. So this is the generic 200. This one we've selected it. This is generic 200. This is generic 200. But when you double click on it, like that generic 200, what I wrote in my Revit. So when you come back here and you click, you see this generic 200. That is what has been exported to structural analysis. Then the same name, you can write anything you want. So when I double click here twice, thickness is 250, but actually this is just the name that is generic 200. Yeah, the real thickness is 250. Yeah, then my material, I'll change it to grade 30. I think this I'll add. Yes, if this was going to be buried, water tank, you on the walls too, you are going to have some soil pressure, but we'll only do that on our foundation slab, since we are assuming that this concrete structure is not buried. So now we'll add. It's telling us yes, modify it. Now we'll close, we'll apply. Good, we can now close. We've done this. So the next thing we are going to do is we are going to assign support for this one that is going to lie on the floor. So how do we do that? We'll come to here is support. But we want to apply planar support. Yeah, I'll click on support. This page come here. So we'll click on planar. Then we'll click on new. So when we click on new now, we'll come to elastic. So we can rename the label elastic. We rename the label as elastic support. We rename the label as elastic support. So see, maybe sometimes if you come now, all this you restricted in all places. So make sure that it's now release X fix. These are the directions that are fixed. The X and Y direction. We'll now add close. Then we'll now pick. Why are they two? Let me go back. Good. Yeah, this is the one that has the setting. This one. Then I'll now select. This is current selection panel 5. Good. Okay, we have done that. So the next thing we are going to do is we define our loadings. So the next thing we are going, if you can see now, all these loadings is not us. They're just follow combos. Now we'll come to, for you to get your loads in this place, load types. So when I come here, I'll delete everything that is here. Delete all. Good, it's empty. So the first load will be dead load, which is the self weight. The dead. Alright, this is self weight of my structure. Or add. Yes, if this is a swimming pool, you can also do another one for services and the rest. But I'm assuming it's a conch water tank and they're not going to have finishes like tiles and the rest. So the next load will be my live load. We'll give it live load and it's going to be water pressure. Going to be water pressure. I'm going to add, and at this juncture I'm going to close this. So we're now going to apply these loads. So if you come here, self weight. So for you to see these loads, whether it's been applied or not, there's a load symbol. You activate this load symbol, you can see that this one is the self weight, water pressure, self weight. Good. So now we're going to now add our water pressure. So before you add the load, you come here and choose it. So now we have choose water pressure. So we'll select this. So we select it yet? Yes, we can select it. They will now come here, load definition. I'll click on load definition, then surface. Under surface, this is, we'll now say uniform load. The loads are going to be acting on here. Click on uniform load and the depth. And the depth of this is Z. So like this, in the Z direction, this is Z, the vertical direction. We're going to have minus 40 kilonewton or kilopascal, the same thing. How do we do that? This is just 40 times 10. 4 times 10, the height of our concrete water tank times the gravity 10. We can use 9.8, but I approximate it to 10. So I'm not going to add. I've added. So this is the only member that has been selected. I'm going to apply. You can see that the load is acting downwards. I'll close that. So now I'll select these walls, right click, select by thickness. even though the down one too have the same thickness, this select. That's nice. So select by thickness. So see this place, edit in new window. I'll like click on edit in new windows. So it's only this one that I'm seeing. So I can click the top of this. It's fine. So there's another thing here that I'm going to activate, local systems. Yes. So you see this red is showing how the water pressure will push. But I want everything to push out. But it's only these two that are pushing out. So I want to mirror this one too. How do you do that? See, if I click here, it won't answer. So I'll come to geometry. Under geometry, I think under geometry, I now come to local panel direction. Good, this has been activated. So I've changed. Then I've left click on change local axis Z. So by the time I select this one and I control select these two, I'm able to apply. Good, see that now you can see that that direction is now showing outside. So by this, if I apply the pressure, it's going to be pushing out instead. So I'm going to get a more accurate result. I can cancel that. I don't need it for now. So I'm seeing other case 2. We'll load case 2. You can't stay here and add water pressure, is wrong. You can come to load case 2. So under load case 2 now, I'll still come to this place. So this time surface, it's still surface, but it won't be uniform. I'll now come to hydrostatic pressure. I'll click on hydrostatic pressure. Okay, so for some reason we are using the unit weight of water, or is 1000. Is this very, very simple with little knowledge of structural design? You can do this. The unit weight of water is 1000. What is the height? 4 meters. I'll add. Then I'll now select. As I'm selecting these walls, you can see pressure is adding. It's push adding on the wall. So I can now close this. So I can see left click on exit. You can see that you can come back to rotate. You can see my pressure. Good. So the next thing I'm going to do is I'll do load combination. I'll come to load, manual combination, ultimate limit state, ULS. Okay. So I'll select this first one. See, you can type your factor here. So the self weight is dead load 1.4. I'll move it to this side. The water pressure is 1.6. I'll move it to this side. Then I'll say new. Yes. So this time serviceability limit state. I'll say okay. So I'll move this one 1. I can now apply. I'll close. So if you come here now, you see that you have ultimate limit and serviceability limit state. So I'm going to mesh these walls. So I'll right click and see select similar by thickness. I've selected all the walls. Then this is then these two now. This is the mesh option. I'll click here, then generate mesh. As you can see, we have no errors. So since we have done our load combination and the rest, we are going to analyze. Okay, now we're done with analysis, so let's take a look at our result. We'll come to maps. Under maps, let's see. Under maps, let's see our moments. Click on moments and apply. Good, we can see our moments. Let's change it to ultimate limit state. Wow, okay, let's see. This is ultimate limit state. Let's rotate. We're in the X direction. Moments in the Y direction. Okay. Stresses. Okay. The soil reaction. Shear forces. Okay. The other things here. Can take a look. If you don't like this, can use automatic scale. This more. Okay, so in our next lecture now we're going to do we're going to check for deformation, we're going to check for deflection, crack width, and check reinforcement required and reinforcement provided. Then we can do the detailing of the RC water tank. So in case you need in-depth training on any of these softwares, you can contact me. This is my WhatsApp number, this is my website, and on our website we have services of architecture, design, structural design, M&E services, and then under the academy you can download videos on BIM softwares. You can download softwares. We have a lot here, so you can check it out. So, and under the description to this video is a link to our WhatsApp group, so if you're interested to join us on WhatsApp, you can also join us. Thank you, and remember to subscribe to my channel, and there is more to come.